The manipulatives that we use in mathematics don't have to be expensive or terribly fancy. The standard Dominoes set can provide a lot of good, really rich tasks for us to try, but let me just suggest one or two. I often tell children, particularly young children who've never used Dominoes before, that there are some properties that we need to worry about. And I tell them a little train story. So what we're going to talk about is the train where there's 10 people on a train. So in this case here, we might notice that I'm going to call this a train carriage. There are 2 compartments, and just happens to be in this case there are 5 people or 5 dots in this compartment and 5 dots in that compartment. So altogether there are 10 people on the train. So I want to look at how children count and how they do things like subitizing and seeing those 5s, but now I'm going to put into a problem solving element. So even very young children can do this problem solving. So let's take that one away. Let's imagine that we have a train carriage and we already know that there's 4 people sitting in this one and 2 people sitting in that one. So there's 6 people altogether on there, 4 in that compartment and 2 in that one. If I wanted to join another carriage to it, there's only one joining rule. And the joining rule is this. The joining rule says that there's got to be exactly the same number of people sitting in a compartment of the carriage in order for them to join. So I can join those 2, but I'm not allowed to join those 2 because there's not the same amount. And really this is a matching idea. So the problem is, can I make a train that holds 10 people and the number of carriages doesn't matter? So let's have a look here. I could try that, but I don't think that's going to work for what I want to do, so let me try another one. So in here, let me just think about it. So I've got 4 people there, 2 more there is 6, 7, 8, 9, 10. So that would be an example of a train. It's joined 2 dominoes. The joining rule is there, same number of people in a carriage, and the total number of people is 10. So here's the task. How many different trains can you make that hold 10 people exactly? Now they could be short trains, something like 5 and 5. They could be longer trains. So how many different trains can we make, and how will we know when we found them all? And sometimes if children are only making very small trains, I ask them what's the longest train that they can make. There's some seriously good problem solving here. Likewise, they can record this because all they need to do is draw a rectangle and put dots in it. Sometimes the children say, I'm sick of putting 4 dots, and they want to know if they can actually use the numeral 4. And that's a really good thing because they start to get the power of symbols to show that the number 4 represents those 4 dots. So try it. Remember the question? How many different trains can I make where there's 10 people travelling on them? Remember, you must have the joining rule.